another exciting FSA practice packet. Dun 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 dun. Okay, so we're going to go ahead and work on correcting our packets today. Remember, with your corrections, as long as you write down everything I've written down for the problems that you've missed, or if you don't have any work to show for these problems, you need to write down exactly what I write as well. You will get full credit for this 100% if you write down what I write down for each of these problems. Okay, so make sure to do that on your packet or even on a separate sheet of paper if you need to do that. Okay, this first problem says city planners are creating a neighborhood map on a coordinate grid. The table shows the locations of the neighborhood library and school on a coordinate grid. So here are the locations. I'm going to go ahead and write them down. -4, -6 is the library, so I'm going to go over to -4, down to -6, and put a dot. I'm going to label it L because that's the library. And the school is at 5, -6. So I'm going to go over to +5 and down to -6, and I'm going to put a dot. And then I'm going to label that S for school. The question says, in this coordinate grid, the distance between each grid line represents 1 mile. That means each of these points represents a mile. What is the distance between the library and the school on the grid? It's wanting the distance, which means you don't just want a number here. You want the distance that it's talking about. It just said that the distance in this grid, each of these points represents 1 mile. So our answer needs to be in miles. So many miles, however many they are. So let's count the distance between the library and the school. I'm going to use jumps because that's what I like to do. Make sure that you are counting with each jump. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 jumps, and that represents 9 miles on this grid. It says, of the labeled points in each in figure 1, which is exactly 7 units from 9-4. So 9-4 is, this is 10. So 9-4 is 1, 2, 3, 4. 9-4 is here. Okay, and then we want it to be 7 units from 9-4 and 12 units from -3, -3. So I'm going to go back -3, 1, 2, 3. And down -3, 1, 2, 3. So this point is -3, -3. So if I wanted to figure out if this was 12 units away from -3, -3, I'm either going to go left, up, to the right, or down. Well, if we go down, that's not 12 units. And if we go left, there's not any, there's not enough room enough for 12 units. And if we go up, there's no labeled points around 12 units if we go up. So we need to go right 12 units. So I'm going to show this in blue. Oops, not sky blue. Dark blue. Okay, so I'm going to count 12 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, it says that point F is 12 units from -3, 3. So, good. F is 12 units from -3, -3. Okay, and we want to make sure that this point is also 7 units from 9-4. So 9-4 is up here. I'm going to count down to make sure that it is exactly 7 units. So 1, 2, 3, 4, 5, 6, and 7. Yes, it is 7 units from 9-4 and 12 units from -3, -3. Okay, so F is our answer here. Point F is located exactly 7 units from 9-4 and 12 units from -3, -3. Now, remember when we are dealing with coordinate grids, this is not asking for this in this particular problem, but we want to remember that our quadrants, there are 4 quadrants in coordinate grids. The first one is in the top right corner. The second one is in the top left. The third one is in the bottom left, and the fourth one is in the bottom right. Remember, the quadrants are always located in the shape of a C, 1, 2, 3, and 4, and they are always using Roman numerals. So F is in quadrant 4. Again, it didn't ask for that information, but I wanted to review it while we were on this particular problem. Make sure to write that down on your paper as well. Okay, pause this video at any time too that you need to slow things down and write things down. It says an expression is shown 7 times 7 times 7 times 7 times 7 times 7. What is the expression written in exponential form? Remember, exponential forms means that we will have a base and the exponent will be really small at the right of our base, at the right and above our base. So our base is going to be the number that is written over and over and over again. So our big number is 7, that is our base. And our exponent is going to be 1, 2, 3, 4, 5, 6. It's how many times that number is written. So 7 to the 6th power, that is our answer. That is our expression written in exponential form. Remember, this answer is not going to give us 7 times 6. That is not right. Not at all. You never multiply the base and the exponent together. You want to multiply the base times itself that many times. So this would give us a really large answer if we had to actually get our value of this answer. It didn't ask us for the value, it only asked us for exponential form. But if it had asked us for the value, we would be multiplying 7 times 7, which is 49, multiplied 49 times 7 and get that number, and multiply that number times 7, and so on and so on. So it would get to be a really large number for this problem. Just keep that in mind. Write an expression that is equivalent to 5 times 5 times 5 times 5 times 5. Remember, that number that repeats is our base. The small number is how many times that is repeated. 1, 2, 3, 4, 5. So 5 to the 5th power is our answer. Which expression represents 6 more than x? Remember, this word's more than means to add. So 6 more than x. This is as far as we can take this problem. It did not tell us what x was equal to. If in the problem it said x is equal to 1, you could add 6 plus 1 and figure out that it was 7. But it didn't ask us for this problem. In this problem, it did not ask for that information. It just said which expression, okay, which means there is no equal sign. That would be an equation, not an expression. An expression is just a number, an operation, and a variable. So 6 plus x is our answer here. Okay, this says read the statement and identify the expressions that are equivalent. Select all that apply. Sum means we are adding. The sum of a number times 3, times means to multiply. We don't know what the number is, it doesn't tell us, so we'll just use the variable n. So a number times 3 and 15. That means we are adding. And means to add 15. So the sum means we're adding. So we are adding 3 times n plus 15. So 3 times n plus 15. The equivalent expressions we want to be equal to this one. So this says 15 plus 3 times n. That is correct. They use the commutative property to move the 15 to the front of the problem instead of the back, and that's okay. That worked out. The next one says 3 times 15 times n. That is not correct. 15 plus 3n, that is correct. Again, they just use the commutative property to move that 15 up front. The next one says 15 times n. Again, 15 isn't the number that's being multiplied times our variable n. The next one says n times 3, which is correct, plus 15. And then the last one says n plus 15. Again, we weren't adding n to 15. We were at multiplying n times 3 and then adding that to 15. So our first, third, and fifth choices should have been checked off. And I know my checks are backwards to everybody else. They are actually correct for me. I'm left-handed. So my apologies. All right, it says write an expression that is equivalent to 3 times 2n plus 3 plus 9. I'm going to use the distributive property to distribute the 3 to everything inside the parentheses. 3 times 2n is 6n. 3 times 3 is positive 9. And then we have a plus 9. Remember, we can combine like terms. So our two 9s can be added together to give us 18. And this is as far as our answer goes. Remember, you cannot add variables to numbers without variables. You can multiply them like we did here. You can certainly multiply them, but you cannot add or subtract them. That will not work. Multiplying, yes. Adding and subtracting, no. So this is as far as it goes unless it told you that n was equal to a number, but it did not tell us that, so that's as far as your answer goes. Okay, it says write an expression that is equivalent to z plus z plus z plus z. Well, there are 4 z's, so our answer is 4z. Easy enough. Okay, which expression is equivalent to 21x plus 9 minus 3x? Sorry. We want to combine like terms. Our like terms here are 21x and minus 3x. We want to put those together. So 21x minus 3x's. This is like counting anything, right? If you had 21 Coca-Colas and you're subtracting 3 Coca-Colas, how many Coca-Colas are left? It's just a simple subtraction problem. You have 18 Coca-Colas or 18 x's left in this problem, okay? But do not forget about the 9. The 9 is still part of your problem. You just cannot add it to your 18x. It won't go together. So you're going to have to keep them separate and show that you're adding them with the plus sign. So we have 18x plus 9. So we want to figure out which of our A, B, C, or D will give us that answer. So I'm going to do A up here. Remember, when we have a number outside of the parentheses, we can use the distributive property to multiply it times both of the variables or numbers on the inside of the parentheses. 9 times 2x gives me 18x, and 9 times 1 gives me 9, and we want to bring down this subtraction sign. So A is not correct because our answer says we are adding 9, not subtracting 9. B says 9 times x plus 1. 9 times x is 9x, and 9 times 1 is 9. We want to bring down our plus sign. 9x plus 9 is not the same as 18x plus 9. C says 9 times 2x plus 1. We want to multiply that number on the outside by both numbers or variables on the inside. 9 times 2x gives me 18x, and 9 times 1 gives me 9. We want to bring down that plus sign. This one is correct, okay? We figured it out. It is C. C gave us that 18x plus 9. I'm going to finish this off with D, though, just to show you that it is not correct. We have 18 times x plus 1. 18 times x is 18x, and 18 times 1 is 18. Bring down that plus sign. So that is not equivalent to our expression that we wanted. These two match. So our answer choice here was C. Almost done. Okay, it says an equation is shown for t equals 50. What is the value for t that makes the equation true? Remember, when we are solving equations, we want to solve them by doing the opposite of what it says. When we go to solve something, we work backwards, okay? Like if you're solving a mystery, you start and work backwards to figure out what happened. Okay, I start by drawing a line down from my equal sign, and then I see what is happening to my variable. In this problem, my variable is t. Right now, t is being multiplied by 4, so we want to do the opposite of that, and we want to divide both sides by 4. Whatever you do to one side in an equation, you have to do to the other side. 4 divided by 4 is 1, and 1 times t is t. And 50 divided by 4 will give us our answer. So 50 divided by 4, 4 goes into 5 one time. 1 times 4 is 4, subtract and we get 1. Bring down our 0, 4 goes into 10 two times. 2 times 4 is 8, subtract, 10 minus 8 gives us 2. Now we can do one of two things. We can bring up our remainder and our divisor will follow, and that will give us a fraction, and that would work. Or we can put a decimal, and annex a 0. 4 goes into 20 5 times. 5 times 4 is 20, subtract and we get 0. So our answer is t is equal to 12.5, or 12 and 5/10. Okay, an equation is shown. 1/8 times r equals 1/4. Again, we want to do the opposite and work backwards in order to solve our equation. Right now, our variable r is being multiplied times 1/8. We want to do the opposite of that and divide both sides by 1/8. This is going to cancel, and we are left with r is equal to 1/4 divided by 1/8. When we are dividing fractions, we want to multiply by the reciprocal of the second number. So we want to flip the second number and change our sign to multiply. 1 times 8 gives us 8. 4 times 1 gives us 4. And 8 divided by 4 gives us 2. So our answer here is r is equal to 2. Okay, that's all I have for you guys. I hope you guys have a fantastic day, and I will see you soon.